On Monday, we talked about how the Pythagorean theorem is an equation that will help you find the missing side of a right triangle. That is to say that if we have any two sides, we can always find the third side. So I want to start with that prospect today, and really to use this equation successfully, you have to identify your missing side, so let's call this x, and the equation obviously has different pieces, so like it has an a and a b. The a and the b are always going to form two sides that connect at the 90-degree angle, and we call these legs. That's for a and b. So you can let a be 9, b be 3, or you can switch those and it won't matter. So a and b are really just interchangeable. So I'll go ahead and plug those two in. And then the last part is not a leg. That's always across from your 90-degree angle, and we call this a hypotenuse. I can't stress enough how much you'll need to know this in geometry. So we'll just call this our c value, and let's solve for x. So we take 9 squared and we get 81, 3 squared and we get 9. From here we would add 81 plus 9 to get 90. And we would take the square root of both sides to cancel our degree of 2. Okay, now the square root of 9 is 3, but the square root of 90 is not 30. Recall what a square root means. It means that the number underneath needs two identical numbers to multiply by itself to give me 90. So like if I did 30 as my answer, that's not true. So in other words, I need to figure out, well, what is this answer? Now the first thing you can do is you can put it into your calculator. And you get approximately 9.48. Now this is a rounded value, which is why I'm using the approximate symbol, and it's rounded to the hundredths place. To avoid having a rounded answer and having an exact answer, we're going to reduce. Okay, so this is not reducing. This is just putting this into your calculator and hitting enter. If you want to reduce the square root of 90, you're going to take a simple mathematical law which states that if you have a radical, so I'll come back to this, it states that if you have a number, let's say under your radical, let's call that number a times b. Okay, now a times b we're seeing as the square root of 90. So we want to take the square root of a and b and we want to split it such that a and b are in separate radicals. Now a couple ways I could do this. I could do the square root of 1 and the square root of 90. Now I couldn't do this. Okay, you see why? It's because it doesn't have these radicals. Okay, so just real quick, we said that the square root of 90 was approximately 9.48. If you do 1 times 90, that's 90. Way bigger than 9.8. So there are other ways you could do this. Like you could separate this into 3 and 30. You could separate this into 9 and 10. Okay, anything that will multiply to 90, but you have to have those square roots on there. So when we think about splitting these two apart, I start off with 90 and I think, okay, well, what's the two numbers I think of that multiply to 90? How do I choose those two numbers? What you want to do is pick one number that's a perfect square, okay, like 9. And then you have to think of what number goes with it to give you 90. And of course, 9 times 10 is going to give us 90. All right. Then you take the square root of that perfect square, which we already know square root of 9 to be 3. And then we keep the other one just the way it is. And this looks really strange, but it is simpler than radical 90 in the sense that it is smaller and easier to deal with, and it is not rounded like 9.48. Okay, I want to look at a couple more examples on how to choose your number. Let's say you had the square root of 100. Now we know this answer is going to be 10. Okay, but how could you split it apart and still get the same answer? Well, like I said before, you want to think of a perfect square. So if I think of all the numbers that multiply to 100, that would be 1 and 100, 2 and 50, 4 and 25, let's see, 5 and 20, 6, 7, 8, 9, 10, and 10. Okay, so what I told you was we needed to pick a number that was a perfect square. So ask yourself just real quick, maybe you pause the video, which one of these numbers are perfect squares? Okay, I want you to circle them. You should have chosen these two, and that's it. Okay, so 1 and 100, square root of each of those is 1 and 10 respectively. And the square root of 4 is 2, while the square root of 25 is 5. All these other ones you can eliminate. So how do you choose between these two then? What you need to do is pick the pair with the largest square. So the largest square is 100, so that's the one we're going to pick. Square root of 100 is 10, square root of 1 is 1. Final answer is still 10. Now that's a really roundabout way to do that answer, right? Well, that's because this is a perfect square, and we don't need to show our work for that. So let's look at a different one. All right, let's look at the square root of 112. So I got to think, okay, what's a number that goes into 112? And you might think, hey, it's even. 2 goes into that. Okay, I'll buy that. Now, here's the deal with that. You have a non-perfect square there, 2. So you've got to hope now that this is a perfect square. And what do I mean by non-perfect square? It means when I take the square root of 2, I get 1.414. It's not a perfect square, but rather a decimal that goes on and on and on. So let's see, divide 112 by 2, and we get 56. Okay, well, the reason I did that is now I know what to multiply 2 by to get 56. And you'll see I also can't take the square root of 56. If I do, I get something like 7.48 ... So we need to think of a new number. Don't just go with what's easy, but follow the instructions of has to be a perfect square, the biggest one if you can. Sometimes it's easier if you can just list out all the numbers. So let's go ahead and just list all the factors of 112, shall we? We get 1 times 112, 2 times 56, 4 times 28. What else? 7 times 16, 8 times 14, and I think that's it. Okay, so just take a second, see if you can figure out what the biggest perfect squares are. You should be looking at these 3 choices because of 1, 4, and 16. You can take the square root of all 3 of those. They are 1, 2, and 4 respectively. Now, I'll tell you, 1 is never going to be the biggest perfect square ever, okay? So we're going to eliminate that one. We know we're not using these 2. And the biggest one between here, you might think, oh, well, 28's the biggest number. But remember, 28's not a perfect square. 16 is. So we're actually going to go with 7 times 16. 16, square root of that's 4. And you might say, okay, well, this is my answer. But let's say you were a little sloppy and you accidentally did that. Now my answer looks like the square root of 74. So to avoid that, I want you to make sure, and remember, I don't know if we've talked about this in algebra, I definitely know I talk about it with my geometry students, that you need to always make sure you're putting the number with the reduced value on the left. Okay, so your answer is 4 radical 7. Just a quick pause. We're going to switch gears on how we're figuring these out. I'm going to throw some different types of problems at you, but just to keep in mind, what are some perfect squares that you need to know off the top of your head? Those are going to be 1, square root of 1 is 1. 4, square root of 4 is 2. 9, square root of 9 is 3. And so on. If you feel fairly comfortable with your squares, you can skip on ahead. Let's say you have 2 squares that you want to multiply together. Okay, well, the rule here is to multiply the inside numbers just together like normal, but keep them underneath. And if there's an outside number, you want to keep that on the outside as well. Let's add 2 to this just to make it a little bit more complex. Let's put a 2 here and a 3 here. And since those are on the outside, we'd have then a 6 out here. 2 times 3 is 6. And then you switch to the inside. 4 times 6 is 24. Okay? Now we have to reduce our answer here, but remember, the only part that needs reducing is the square root of 24. We will then take that and multiply by the 6. So I'm going to go ahead and just over here say my answer is something times 6. Okay, some reduced value times 6. And we're going to take 24 over here, split it apart. And if I list all of those, looks like I get that list there, and it looks like the biggest perfect square in this list is 4 and 6. Square root of 4 is 2. Square root of 6, we'll just keep. Okay, so if I drag my answer over here, I have to multiply that by 6 because that's what I got from the original part. Now, would the 6 go with the 2 or the other 6? It'd go with the 2 because they are both without a radical. So your final answer here is 12 radical 6. Our last example here is just to show you how to do this when you have a fraction. So let's say you have the square root of 49 over 100. Similar to multiplying, you can split this apart as well. So I said earlier, if you had a times b, you can split this up into the square root of a times the square root of b. Well, now we can split this apart just vertically rather than horizontally. Look familiar? The square root of 49 is 7. Square root of 100 is 10. Now, obviously, these can get complex in the sense that, like, what if this was the square root of 48? Well, now it doesn't turn into a magic 7 like the top did for the original. We'll look at more of that on Friday. Okay, go ahead and look at the Pearson assignment for simplifying square roots. Make sure you've already turned in the other assignments from the last 2 days. Make sure you're looking on the calendar. And we'll finish up with very, very similar material on Friday. Thanks, guys.